All right, everyone, welcome back to Money Show's Virtual Expo. We are pleased to welcome Mansour Khatib. He has studied electro engineering and economics and has marketed numerous multi-million-dollar consumer websites. He has a passion for business startups and became CEO of GBT Technologies Incorporated at the height of COVID. In 2021, Mr. Khatib began turning GBT Technologies into an IP company, creating a portfolio of technology patents. We are also pleased to welcome Danny Rittman. Danny leads the technological direction within communication, AI, cybersecurity, and EDA domains. He has served as a senior IC design consultant for several leading technology companies and has received a BSc degree in electrical engineering from the University of Bridgeport, MSc from Colorado Technical University, and a PhD degree in computer science from LaSalle University. Dr. Rittman completed professional courses of machine learning at Stanford University and AI in healthcare at MIT. He has published technical papers in Frontier and other technical publications as well. Mansour, Danny, welcome. So glad to have you here. The floor is all yours.
Thank you. Welcome, everybody. Good afternoon, everybody. I am happy to say hello to everybody and greet you, and for everybody who's here. This is the very first event of GBT ever, especially in the combination of Danny and myself. We're discussing a product or topic today where I have the outline. It's called Microchips, the gold of the 22nd century. This will be more a narrative story. We want to tell you a little bit how we came to the decision, what we're going to do, and why we're doing certain things. In 2019, I read the first articles about what's called the Chips and Science Act, and I was thinking, oh, something was going on in the industry. And also at the same time, we were starting and finishing one of our patents, called 3D multi-planar chip. We were in the midst of it. We started originally with go for inside chip because Danny has a background in IT and computer chips, semiconductors development. And of course, we all know then COVID started, the change of 2019, 2020. In 2020, the company, we lost our CEO, we lost some board members, and the company needed a new direction. I joined, I was there before, but I became the CEO of the company, taking over responsibilities as the CEO. And that was in probably May, June 2020. This was a difficult time for all of us. And we sat down together, Danny and I, Dr. Rittman and I, we sat down together to explore where do we go as a company and what is the strategy. And we really, really, really looked deep on what we have and what we have done in the past and where the future goes. Putting this all together, we realized that IC chips, and number one, that we have a whole bunch of IP over the years that we developed, but not really finished. We kind of started many ideas, but there was no concentration. That was the first thing. Number two, we had a lot of great concepts. And then number three, we needed to market. So we looked at this and decided that really our strength is in developing new technology, coming up with new ideas. And then with the background of the CHIPS Act, we also realized that the IC community, that there's a lack of good IC technology, or that there's a lot of improvement what could be made within this industry. I could now discuss up and down, left and right, why this is, and I could come up with certain examples. I, for example, myself believe that there's at least like $5 trillion of legacy equipment laying out there what needs upgrading in the IC world worldwide. Thinking about this, I just make the case very simple. Why would or should we all look at microchips for the future? And I will make it easy. This is my first slide. Just look what's going on right now in the world. Right now, the USA has a CHIPS Act, Science and Chips Act, investing $250 billion. Europe is investing something similar, 160 billion. Korea, 450 billion. India, 12 billion. They really need 80 billion to make it happen, to get into the chip arena, chip manufacturing. $39 billion from China. They probably will step it up. And there's commitments, if you just scatter the internet world, there's probably commitments of at least 1.38 trillion dollars from chip makers and related business. The real number is probably higher. So that means that we have just this year in 2022 had investment announcements in excess of $2.3 trillion worldwide. New expectations, Fortune Business Insights is projecting around a business that the business growth of the microchip industry to around $1.136 trillion per year by 2028. What that really means is we will double, the microchip industry will double their sales within the next 6 years. What is huge? There's many political issues here. Obviously, we all kind of know China, the shortage of chips via COVID. But one of the main reasons is really that we need more chips for the future. We need chips to repair the legacy systems. We need chips for new technology like AI, because AI needs very, very powerful parallel chips to work in the future. We need more memory. And and then we have a growing market. We have drones, we have phones, we have other computers, we have tablets. Everything will be data, and there's a big fight, and whoever wins this fight and puts enough money into the game will be leading the world. At least that is our opinion. So at that stage in 2020, end of 2020, beginning of 21, Danny and we decided, okay, let's concentrate our efforts. Let's bring some families of technology together, concentrate and develop patents around this as a strategic decision, and go with those technologies, develop the IP, and basically grow with this huge market of semiconductors. So we have families of AI. We have a computer vision system, what's security and health. We have cybersecurity. We have a 3D multi-planar chip hardware. We have an IoT mesh network, what is patented. We have advanced radio networks and radio technology. We have tracking with and without GPS. We have health technology, telemedicine, and EDA tools, what support better chip design, green chips, and also more powerful, better quality chips. This is what we decided in end of 2020-21 to change our strategy and really becoming and changing into an IP company. And we are still in this change. However, because of this, we have now rewritten our progress and exit strategy. We are currently not looking, obviously everybody's looking for value, but what we really measuring our success is on patents and approved patents. So to give you some ideas, right now, this year, by 2022, up till today, we have 8 approved patents in different areas. We probably have around 7 or 8 other patents pending, what we have submitted. And our goal is by the end of 23 to finish up certain families of patents and have around 20 patents approved and probably around 32 altogether submitted. This is a strategy, especially in the patent world. Most companies don't buy one patent. Most companies buy like a little family. So that's why you see when you look, if you would follow us or you follow the company, you would see certain repetitive patents. You see that we have the 3D chip, we have like one patent, and we have a secondary patent. We filed a third patent now for it. And so we're building a little family, and this is it's called idea fencing. And that's what basically all larger IP companies do. We are just very small. And our goal is to generate a big enough portfolio and those families by the end of next year, so we can take those ideas and sell or license the family to another company. So this is all. So apologize, I'm one too fast. So this is our exit strategy. Now the question for everybody is, what is our chance to position such a package in front of a large company or in front of a large venture capital company? And for that, you need to understand our technologies. I gave you a whole list of technologies. Dr. Danny Rittman will now have the chance to explain 3 of the technologies, in more or less layman's terms. We will try to make it simple so you understand the effects and the advantages. We do the 3D chip, we do the Apollo computer vision system, and we do the EDA software. And for more detail, you can send us information, you can send us questions, and we posted videos and presentations and more information on this show booth, what should give you plenty of opportunities to look a little bit more in detail. However, with that, I would like to turn over to Dr. Danny Rittman, so he has a chance to explain a little bit about 3 of our leading technologies, and I thank you very much. Danny, it's you.
Thank you, Mansour. Thank you for this. So, hello everyone. As Mansour said, we have wide range of technologies. So it can take me way longer to do so. I'll try to focus today on basically 3 of the major technology that we are involved with. I guess when I started at Intel Corporation in the early 80s into the microchips arena, I couldn't imagine how big it's going to go and how it's going to become such a major topic in our lives. Today we have microchips almost everywhere. We have it in our computers, in our phones, and basically even toys. So everything today speaks and makes lights and does lots of gizmos and nifty things, but it's all the core of all this is basically a microchip. So basically GBT technology was born into the microchip or with the microchip technology and in 2018, 2019, when we came out with a few concepts of chips, but one of the most innovative one was actually a 3D multi-planar chip. To make it simple, the way microchips are made today, basically they are etched or they are produced, to make it simple, into a silicon wafer. Silicon wafer is a piece of silicon cut in a circular shape, and machinery, advanced machinery, basically etching, creating the chip into small squares, and that's how it's made. This is a traditional way that's been done for years, decades. And the problem with this is, as microchips going larger, become huge and small process, we talk about 7 nanometer, the 3 nanometer, 5, they're getting smaller. It's become way more challenging to actually place and pack chips with more circuits, to consume less power, less heat to produce, and all this. So we came out with a concept to create a 3D microchip, but not just a 3D concept that basically was already developed about a decade ago. We took it one step further. We said we're going to make it what we called a planar, multi-planar chip, means instead of just make the chip on a flat surface, as basically it's been done traditionally for the past few decades, let's put it in a much more multi-planar form. In this way, we increase dramatically, exponentially almost, depends how many planes we have, the amount of chips we can put on a die, on actually a piece of silicon. And we can actually, I can share very quick, Mansour, if you let me, I can show what the concept is about. Imagine, thank you. So if we look basically on a planetary object, and as you see here, this is starting with a cube. So assuming instead of a flat surface, I actually can put a microchip circuitry on each plane of the cube. Just by that, I enhance it, by many times. If I go even furthermore into a more multiple planar, and on each plane, I will put also some circuits, I create another level of high capacity manufacturing for these microchips. Now, of course, you have way more than that. You can have, 10 planes or 20 even, and that's create an enormous amount of microchip real estate to put on a die. And this especially, every chip today, as they become larger and larger, eventually we are getting limited. With this approach, we will be able to exponentially put way number of circuits on the same chip. Especially if we talk about memories and things like this. I'll stop sharing now, so we can be back to that. So in this is one concept that we patented, and we actually did another patent. We have a few patents on the 3D multiplanar chip. We do believe this is the future of the integrated circuits, especially when chips going to become huge, smaller, they need to consume less power. This opens a whole new world of possibilities in this domain. As I mentioned, we have actually granted patent here. I believe we filed another 2 on the way. So we're gonna invest major efforts in this direction, trying to connect with also major manufacturer, TSMC, UMC, and others, get them interested in this type of innovations. The next slide, please, Mansour, if you could. I will talk a little bit now about the Magic 2 as a direct derivative that connect to the microchip arena today is basically EDA tools. EDA technology, standing for electronic design automation, basically are software tools that are used to design the chips or to make them better, to make them to enable designer to design chips consuming less power, consuming less space, working faster, high performance, and do all the magics that we see on our phones or any electronic devices. So EDA technology is a direct control, is a direct effect on the entire microchip design and the whole world. The leading companies in the EDA domain are based here in North America, and they basically provide the design tools to actually design the chips, to do the mass design, the functionality, the actual preparation for the manufacturing, which we call the mask layout design. And eventually from there, when the project is done, it's going to the fabrication plant, they push a button and the chip is going to manufacturing. Since microchips are going small and smaller in the actual node, in the design process, we are talking about 7 nanometer, 5 nanometer, 3 nanometer and below, physics hit us hard. Means we are designers and the actual manufacturer encountering a lots of physics-related phenomena that create long, hard, difficult, complex challenges for the designers to overcome. This, if a chip per se, let's say a chip that is a microprocessor, a GPU or a memory, any type of chip, a design cycle used to be a year, going lower in the node, it can double to 2 years, even more. We provide a Magic 2 technology, a set of EDA tools or tool suite, we call it, that using this suite, it will enable to create this chip, then especially the advanced nodes, much faster. Instead of tackling these new challenges manually and fixing it manually, it takes months, can take years. We basically enable a tool that with a click of a button can do the correction. So the same chip that typically now will take a year or a year and a half to design, using the Magic 2 tool suite or some of the tools that including in that suite, can shrink this design time by 40%, by 50%. Imagine a chip that's supposed to take to design a year, all of a sudden can be designed in 6 months. It's a huge advantage, a huge competitive advantage on others. It will enable faster chips, better chips, bigger chips, stronger, etc., in much shorter times. That's the Magic 2. So this is a direct derivative impact on the integrated circuit world of today. We filed a few patents already. We have, as Mansour mentioned, we have in the plan by the end of 2023, probably to have at least another 10 or 15 in this domain. And we also already have one of the actual tools actually as a product that we are working constantly to develop. So we're investing a lot of efforts in the EDA tools because it goes along with the microchips in microchips world. We call the Magic 2 the productivity enhancement tools. So for example, as I mentioned, if a chip would take 6 months typical to design, we provide this Magic 2 technology, it will take only 3 months. So this is a significant time to market enhancer. And that's the Magic 2. So Magic 2 goes along with our integrated circuit, 3D multiplanar, and other microchip technologies that we involved with. The last topic that I will touch today will be Apollo. Apollo is basically a radio-based, GBT along the years basically dealt with a lot of radio technology. We designed a mesh technology, we designed a radio, tracking-based radio system that can track with and without GPS. So we were heavily involved with the IoT and radio communication area, and we still are. We have a few projects running, in this area. We do research. We invest heavy R&D efforts in this domain. The Apollo system is actually an interesting, innovative idea to create what we call a computer vision, which is a radio-based. To make things simple and short, imagine a router sits in a room. The router transmits some radio waves. It hits some objects, humans or stationary objects. The reflections go back to this box, to this routing box. Behind it goes an AI technology, which we also heavily involved in the past few years. And the AI analyzes these reflections and built actually the image of what the scanned area is. It's completely, it can be 3D. It can scan anything in that range and produce basically a full computer vision on screen. Why such a system can be such a benefit? Such a system can be used in wide variety of applications. For example, think about monitoring people or elderly in a room without any wearables. The system will be able to detect people falling. It will be able to detect a heartbeat, a heart rate, breathing rhythms, because it detects very, very small changes in volume. This is one application. You can put this in a few of them with extenders in a building, and you can monitor a hospital per se with patients. Another one, it can be implemented within a security region. You can just put one in a warehouse, a few of these, and any intruder will be immediately detected wirelessly. There's no need to put any sensors. There's no need cameras. The radio waves here are the camera. They're basically relieving us from actually place cameras in certain locations, etc., etc. It's a huge, basically, saving in apparatus. Another application is security in airports. such a system basically penetrates everywhere. It's a radio system, so I can easily detect concealed weapons, even if they are located in behind, inside body theoretically. So because it penetrates all, we don't need the use again of surveillance cameras, etc. So the Apollo system offers a new horizon, we believe, for computer vision. Another good application is autonomous vehicles. Put a box like this in a car and it can see around it, a mile or 2 miles radius around it, completely knows about every object, about movements, about pedestrian that, half a mile away. This type of technology can be very innovative and very assisting to get the orientation and location of as eyes for any type of application. And that's the Apollo. We actually got a hefty patent for it. We're very proud of it. It was a great achievement. And we continue filing continuation patents for this IP because we believe this type of system can be implemented in a wide variety of applications. That's about the time I have to just give a tip of these 3 technologies we have. As I mentioned, GBT is involved with way more things, but again, our time is limited. One few more words just about AI. We are very also innovative. We started a few years ago, vast efforts in artificial intelligence efforts, implemented in telemedicine. We have a QTEM, which is a human vital device. You can read more in the press release that the company makes. Very smart electronic apparatus that behind this apparatus with the tip of a finger, it can actually run a whole analytics, measuring human body temperature, heart rate, oxygen, and we have plans for the future for it. We also recently have the Hippocrates system, which is a health advisor online at the time, and we plan to continue its development as well. That's when it comes to AI. In the radio also domain, we have the Infinia project, which also continue the investigation and R&D work about the long-range radio system, something that can help without GPS all around the world. That's about it on my part, Mansour.
Yeah, so thanks, Danny. You didn't go and brought out your Rubik's Cube like you do always with me, so I understand stuff better. So so we want to thank everybody. What we wanted to communicate is basically, number one, if you like our technology or not, there's a big opportunity within computer chips and the semiconductor world worldwide. Business will explode. Our strategy is to place as many technologies within this growing industry, growing and hopefully growing with it, and have an exit strategy once we have a large enough portfolio, IP portfolio, to basically license and sell those products. I want to thank everybody for listening. I'm grateful for this opportunity. This was our first official, show we ever done, Danny and I. I don't know. We have maybe 1 more minute or 2 more minutes. If there's 1 or 2 questions, Mark, you want to ask us? That would be awesome.
All right, Mansour. Thank you so much for that presentation today between you and Danny. We had a few people that were wondering, what direction do you feel that the chips of the future are leading? What companies out there are going to be the front runners?
GBT. I know. Of course, I cannot make the statement. Danny, what do you think? I have some comments.
First of all, Mansour said, and he's right. I showed the demo of the 3D on my software, but I didn't want to know if you see it in the camera. Future, by the way. I don't know if you see it well. You see multi-planes of this object, Rubik's Cube, but in multi-planetary. So on each one of these planes, we're going to put an electronic circuit. So our microchip is going to become not only 3D, but also what we call, I think now I see better, 3D but multi-planetary. This is the future. As we talked about, we believe major companies that working in the IC development are the big guys, typically. IBM has huge research in this domain. We know they're working in this. You can read, you know, it's not a secret. You can read online. They are publishing PRs. They're moving forward, lowering the nodes, making smaller chips, 5 nanometer, 3 nanometer, and below. I do believe they will be probably one of the major ones that will come with innovations. On the other side, on the manufacturing side, we do know that the actual major guys in Taiwan, TSMC, also working on all type of, they are the leading manufacturer for many high-tech companies. They're also working on a breakthrough direction, and that's why GBT will be one of those who offer this new concept. You know, the multi-planetary concept will be definitely something that we hope to be taken into account. And of course, all the others, you know, every major one, Intel invests lots of efforts, and of course, Apple and Qualcomm. These are the major leaders in this domain.
So I wanna do my 1 minute spiel. I think we have a big issue in front of us, because over the last 30 years, everybody is shrinking, and we literally hit the limits of the 3 nanometer. And I always say there's really no solution past the 3 nanometer chip. There's nothing. Nobody has anything. They can just, and I would say our chip approach, it's a new manufacturing approach. It has nothing to do with Intel or TSMC. This design could be adopted by everybody. And it's a new approach to make a chip much more powerful and basically grow beyond 3 nanometer, because at least I personally at that point think the 3 nanometer, that's the end of it. Maybe the 2 nanometer, but there's certain things cost prohibitive and more. But thank you.
All right, Mansour, Danny, thank you so much. Fascinating presentation. You're doing great stuff out there. We appreciate it.
Thank you very much.